Hi everyone, welcome to WinPoint online classes. In this session we are going to discuss heating effects of electric current, Joule's law, power, equations and numerical. In this session we are going to discuss this topic and we are going to complete our session with some of the numerical related to these topics. First we can discuss heating effects of electric current. Heating effects of electric current. When electricity is passing through a conductor, when electricity is passing through a resistor, there will be production of heat. It is known as heating effect of electric current, which means if we are connecting a cell to the circuit, 100% of electricity that we cannot use as useful work, some of the energy will be converting into unuseful heat. It is known as heating effect of electric current. If we are allowing the passage of electricity through a conductor, the conductor will try to resist the flow. As a result, there will be production of heat. If electricity is passing through an electronic device, we are not going to get 100% efficiency from any device. A part of source energy in maintaining the current may be consumed into useful work. Rest of source energy may be expended in heat to raise the temperature of gadget. If you are connecting a cell to the circuit, some of the energy will convert into heat. In this session, we are going to discuss how we can use that heat and what are the problems because of that heat. So we are going to discuss one law related to this heating effect. When electricity is passing through a conductor, there will be production of heat. Joule's law. Here there is a conductor, it's a resistor, and electricity is passing through this resistor. When electricity is passing through this resistor, there will be production of heat, and that heat will depends on the amount of heat will depends on the amount of current passing through the conductor. Second one, the time duration and resistance of the conductor. Resistance of the resistor. First one is resistance of the conductor, time duration. Third one is amount of current. Let's write the law now. If there is a current flow through a resistor, there will be production of heat. That heat will depend on square of current, resistance of the resistor and time duration. There are three factors. These three factors are having an important role in the production of heat. For example, if the current flow is more, there will be more amount of heat. If resistor is having high resistance, the production of heat will be very high. If we are transmitting current for a long time, if we are transmitting electricity through that resistor for a long period of time, then also there will be more amount of heat. It is known as Joule's law. Here the heat is common everywhere. In three relations there is heat. So we can take that heat as a common factor and we can write H proportional to I square RT. It is a mathematical expression of Joule's law. H proportional to heat proportional to I square RT. To remove this proportionality sign, what we need to do here? We need to add a constant. It is proportionality sign. We need to make it an equation. We need to make an equation. To convert this proportionality sign into equation, we need to add a constant. Here the constant is 1. So it will be heat equal to I square RT. Very important equation. Now we can state Joule's law. Joule's law. Heat produced in a current carrying conductor is directly proportional to the product of square of current, resistance of the conductor and time for which the current flows through the conductor. Now we are going to derive some of the equations for heat. We have one equation, H proportional to I square RT. From this equation we can derive some of the equation. You need to learn the derivation, at the same time you need to learn the equation. The equations are very important. Here we are going to derive equations for heat. H equal to I square RT, that is our standard equation. According to Joule's law, heat proportional to I square RT or heat equal to I square RT. What is Ohm's law? According to Ohm's law, what is the equation for I? We already learned it. The equation for I is V by R. I equal to V by R. That is our equation. We are substituting the value of I in the above equation, in the previous equation. So what will be the new equation? H equal to, instead of I square, we are giving this V by R. So it will be H equal to V by R whole square. Instead of I, V by R into R into T. We are going to give that square to inside the bracket. What will be the equation? H equal to V square by R square into RT. Is there any term to cancel here? Is there any term to cancel? Yes, the R square and R, it will cancel each other. R square means there are two R. So one R and this R will cancel each other. It will be V square T by R. That is the first equation for. First equation is H equal to I square RT. Second equation is H equal to V square T by R. Now we can derive one more equation. H equal to I square RT. Now instead of R, here it is R. Instead of this R, we are going to substitute other equation. What is the equation for R according to Ohm's law? R equal to V by I. So we are going to substitute that value here. It will be H equal to I square into, instead of R we are giving V by I. So H equal to I square into V by I into T. The I square and I, it will cancel each other. It will be H equal to VIT. These are the three equations for heat. First one is H equal to I square RT, H equal to V square T by R, H equal to VIT. You need to learn the equation. Next one is power. The power is related to work done and time. There are two factors, work done and time. It is a ratio of work done to time. Ratio means work done by time. In 1 minute or in unit time, how much work we are doing, that is our power. If I am doing a work of 1000 joule in 1 second, that is my power. If an electric bulb is doing a work of 100 joule per second, that is its power. So power is always related to work done and time. So we can define power now. Rate of work done is known as power. Work done by time means rate of work done. The equation for power is work done by time. The unit of work done is joule. Work done, the unit of work done is joule, unit of time is second. So what will be the unit of power? Joule per second. Joule per second or watt. Unit of power is joule per second or watt. Equations for power. We are going to derive equations, some of the equations for power. What is the equation, main equation for power? Power P is equal to work done by time. Power is equal to work done by time. Instead of this work done, we can use W. Instead of this time, we can use T. It will be power equal to W by T. This W, the energy, right? W means work done. Work done is energy. Energy is heat. So W equal to H. We can write power is equal to H by T. So there are two equations. Power P is equal to W by T. Power P is equal to H by T. What is equation for H according to Joule's law? Yes, I square RT. H equal to I square RT. H equal to I square RT. Then we can write power is equal to I square RT by T. I square RT by T. That is equation. The T and T will cancel each other. Numerator there is 1T. Denominator also there is 1T. So it will cancel each other. Power P is equal to I square R. First equation. Now we are considering this equation. P is equal to I square R. Instead of I, according to Ohm's law, what is equation for I? I equal to V by R. We are going to substitute V by R instead of this I. Here it is I square. Then it will be P equal to V by R all square into R. Instead of I, we are substituting the equation V by R. So it will be V by R all square into R. We are giving that square inside the bracket. It will be P equal to V square by R square into R. R and R will cancel each other. It will be P is equal to V square by R. Now the same equation, we are considering the same equation. P equal to I square R. Instead of this R, according to Ohm's law, what is equation for R? It is V by I. So we can substitute that value, we can substitute that equation, R equal to V by I. Instead of this R, we are substituting V by I. Then it will be P equal to I square into V by I. I and I, it will cancel each other. It will be VI. Equation for power. There are three equations now. P is equal to I square R. P is equal to VI. P equal to V square by R. There are three equations. Now let's write all the equations in a single page. Equations for heat and work. You need to learn the equations. Okay. H equal to I square RT. That is the equation for heat. H equal to I square R. That is equation for power. Is there any relation between these two equations? Here in this equation H equal to I square RT. Here I square R. T is not there. Next equation H equal to V square T by R. Then what will be the equation for power? The T, just cancel this T. Then it will be V square by R. Next one H equal to VIT. What will be the equation for power? Just cancel this T. It will be VI. So if you are learning this equation, you can learn this. Or if you are learning this equation, you can write this. Commercial unit of electric power is kilowatt hour. Now we are going to discuss electric power. We already discussed it. Power is the rate of work done. The unit of power is watt. To measure the electric current industrially, we need a big unit. That unit is kilowatt hour. Commercial unit of electric power is kilowatt hour. At our home, the electricity measured using this unit, kilowatt hour, 1 kilowatt hour, 2 kilowatt hour. We have also called it as unit, 1 unit, 2 unit. 1 unit is 1 kilowatt hour. It is represented by kWh, kilowatt hour. 1 watt hour is 1 kilowatt is 1000 watt. This also we need to learn. 1 kilowatt is 1000 watt. Now we are going to convert 1 kilowatt hour to joule. Let's do that. 1 kilowatt hour means 1 kilowatt into hour. 1 kilowatt hour, 1 kilowatt into hour. What about 1 kilowatt? 1 kilowatt is 1000 watt. So we can write 1000 watt into 1 hour is 3600 second. So 1000 watt into 3600 second. We are just multiplying it. It will be 36 lakh joule. That is 1 kilowatt hour. Which means 1 kilowatt hour is equal to, we are converting that, we are changing that value 36 lakh. Instead of that we are writing 3.6 into 10 raised to 6 joule. This is 1 kilowatt hour. What is the amount of energy in 1 unit of current? 3.6 into 10 raised to 6 joule. 36 lakh joule. Now we can discuss some of the numerical related to these topics. An electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and 360 watt when the heating is at minimum. The voltage is 220 volt. What are the current and the resistance in each case? There are two cases. One is maximum heating, second one is minimum heating. We need to make two sections. Maximum heating and minimum heating. When you are getting a problem, the first step, you need to write the given values. What are the values given in the question? That you need to write. For that you need to read the question. An electric iron consumes energy at a rate of 840 watt. The power 840 watt means the power is given. So you can write power P is equal to 840 watt when heating is at the maximum rate and 360 watt when the heating is at minimum, and the voltage is 220 volt. The voltage is also given, so V is equal to 220 volt. We need to find the current and resistance in each case. We need to find the current and we need to find the resistance. In second case, minimum, the power is 360, so we can write power is equal to 360 watt and voltage is the same, V is equal to 220 volt, and we need to find current and resistance. It is the first step of every numerical. Write the given values. You will get marks for that. First you need to write the given values. Now we need to find the equations. Which equation is suitable here? We need to find I. The power and voltage is given. Which equation is relating PVI? The equation is P equal to VI. So we can substitute all the values here. Here the equation is for P. We need to find I. So what will be the equation? I equal to P by V. Just substitution. I is equal to P by V, which means I equal to 840 by 220. Then I equal to 3.81 ampere. That is the current in this case. In second case, minimum. What is the power? Power is 360 watt and voltage is 220 volt. We need to find I. PVI. Which equation? P is equal to VI. And what is the equation for I? I equal to P by V. We are substituting the values. Value of P is 360. Value of V is 220. Then it will be 360 by 220 equal to 1.63 ampere. So we got the value of current in each case. Now we need to find the resistance. If we know the value of voltage and current, we can find the resistance according to Ohm's law. What is the equation for resistance according to Ohm's law? R equal to V by I. What is the value of V? 220. What is the value of I? 3.81 ampere. Then it will be 220 by 3.81 equal to 57.74 ohm. In second case, what will be the resistance that we can find? According to Ohm's law, R equal to V by I. The value of V is 220, value of I is 1.63 ampere. It will be 220 by 1.63. Then it will be 134.96 ohm. 100 joule of heat are produced each second in 4 ohm resistance. Find the potential difference across the resistor. First we are writing the given values. The heat is given 100 joule, resistance is given 4 ohm, time is given 1 second, it is 1 second, and we need to find the potential difference. Which equation is suitable here? Here you can use the equation H equal to V square T by R. It's a direct equation. You need to apply that equation and try to solve it. Here I am going to use H equal to I square RT. H equal to I square RT, and the value of H, value of R and value of T. These values is given in the question. We need to find the value of I. So we are going to substitute all the values. 100 equal to I square into 4 into 1. 100 equal to I square into 4. We are taking that 4 to the other side of equal. It will be I square equal to 100 by 4 and I square is equal to 25. If the I square is 25, then I will be root 25. Root 25 is 5. Current I is 5 ampere. We need to find the value of potential difference. What is the equation for potential difference V according to Ohm's law? V equal to IR, that is equation. V equal to IR means the value of I is 5 and value of R is 4. Then it will be V equal to IR, V equal to 5 into 4, it will be 20 volt. An electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power of the bulb? First we need to write the given values. The given values are V equal to 220 volt and I equal to 0.5 ampere. We need to find the power. If we know these values, V is equal to 220 volt, I equal to 0.5 ampere, P is equal to question mark, PVI, which equation we can use here? P is equal to VI. We are just substituting all the values. P equal to 220 into 0.5, it is 110 watt. That is the power of the bulb. An electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of energy to operate it for 30 days at rupees 3 per kilowatt hour? Here there is a refrigerator. The power of refrigerator is 400 watt and it operates 8 hours per day. We need to find the cost of the energy to operate it for 30 days, and for 1 unit 3 rupees. First we are writing the given values. Power is equal to 400 watt and time is 8 hours. First we need to find the energy in watt hour. P is given in watt, T is given in hour. So we are going to find the energy in watt hour. Energy in watt hour means P into T, 400 watt into 8 hours. Watt into hours, watt hour. So we are writing it will be 400 into 8. Energy in watt hour is 3200 watt hour. Just multiply it. Watt into hour, watt hour. Now we are going to convert this energy in watt hour into kilowatt hour. Watt hour into kilowatt hour. How we can convert? Divided by 1000. Energy in kilowatt hour is equal to 3200 by 1000. Now the value will be 3.2 kilowatt hour. It is for 1 day. What about 30 days? For 1 day 3.2 kilowatt hour, then 30 days it will be energy in kilowatt hour for 30 days, 30 into 3.2, 3.2 into 30. It will be 96 unit. So for 1 month 96 unit. For 1 unit 1 kilowatt hour means 1 unit. Kilowatt hour means unit. So it is 96 unit. The cost of 1 unit is 3 rupees. Then what about 96 unit? Cost of 96 units will be 96 into 3. Cost of 96 unit is rupees 288. If you like this video, please subscribe to my channel. Visit our website www.winpointonlineclasses.com. Support us for providing free online classes to everyone. You can always ask your doubts using comment box. Thanks for watching.